Our next topic, Euler-Cauchy equations. A differential equation of the form x square y double dash plus axy dash plus by equal to 0. This type of differential equation is known as Euler-Cauchy equations. Okay, so the second coefficient of the second derivative term will be x square, will contain x square, and the y dash term will also contain an x. So the differential equation is of this form is known as the Euler-Cauchy equation. Now let's see how we can solve this type of differential equations. For solving this type of differential equations, actually we will use some substitutions. For the first substitution is substituting y equal to x raised to m and y dash equal to m into x raised to m minus 1, y double dash equal to m into m minus 1 x raised to m minus 2 in this Euler equation format. By substituting all these terms in this equation number 1, we will get the equation as like this. Now combining the powers of x square and x raised to m minus 2, will get x raised to m. The 2 and minus 2 will be cancelled, and x raised to 1 into x raised to m minus 1 will be x raised to m plus b into x raised to m. Taking the term x raised to m common outside, and the remaining terms while simplifying will get a quadratic equation like this: m square plus a minus 1 into m plus b. This is known as the auxiliary equation, and depending upon the roots of this quadratic equation, there will be three cases will arise for the general solution format of the Euler-Cauchy differential equation. So let m1 and m2 be the two roots of this quadratic equation, and if the roots are real and distinct, then this general solution format will be y equal to c1 x raised to m1 plus c2 x raised to m2. Just replace m1 and m2 by the real roots values. Okay, now the two roots are real and same roots, then the general solution format will be y equal to c1 plus c2 log x into x raised to m. Just replace the value of real number value here as m. Now the last case, if m1 and m2 are the complex numbers, as like m1 equal to alpha plus I beta and m2 equal to alpha minus I beta. Okay, then the general solution format will be x raised to alpha into a cos beta log x plus b sin beta log x. Just replace the values of alpha and beta here, will get the general solution of the given Euler-Cauchy differential equation. Now let's see how we can solve an Euler-Cauchy differential equation. So solve the Euler-Cauchy differential equation x square y double dash minus 4y equal to 0. Okay, I am taking this as equation number 1. So substitute y equal to x raised to m, y dash equal to m into x raised to m minus 1, and y double dash equal to m into m minus 1 x raised to m minus 2. Substituting all these terms in the equation number 1, we will get this like this, and combining the powers of x, we can take the x raised to m as outside like this, and we will get a quadratic equation m square minus m minus 4. This is the quadratic Euler auxiliary equation. So the roots will be m equal to 1 plus or minus root 17 by 2. So let m1 and m2 be the two roots. We will get m1 equal to 1 plus root 17 by 2, and m2 will be 1 minus root 17 by 2. Here the two roots are real and distinct. So the general solution format will be y equal to c1 x raised to m1 plus c2 x raised to m2. Just replace the values of m1 and m2. We'll get the general solution as, the general solution will be c1 x raised to 1 plus root 17 by 2 plus c2 x raised to 1 minus root 17 by 2. The next problem, solve the Euler-Cauchy differential equation 5x square y double dash plus 23xy dash plus 16y equal to 0. Substituting all these terms, y double dash as m into m minus 1 x raised to m minus 2, y dash as m into x raised to m minus 1, and y as x raised to m. Combining all the powers of x square and x raised to m minus 2, we will get x raised to m. X raised to 1 into x raised to m minus 1 will get x raised to m, and all the terms contain x raised to m as common. So taking it outside, we will get an auxiliary equation like this: 5m square plus 18m plus 16 equal to 0. So the roots are minus 8 by 5 and m2 equal to minus 2. Here the roots are real and different. So the general solution will be y equal to c1 x raised to m1, replacing m1 as minus 8 by 5, and c2 x raised to m2. m2 is minus 2. So this is the general solution of the given Euler-Cauchy equation. Now the next problem: x square y double dash plus 0.7 x y dash minus 0.1 y equal to 0. Substituting all the terms, y double dash as m into m minus 1 x raised to m minus 2, and y dash as m into x raised to m minus 1, and y as x raised to m. Combining all the powers of x and taking x raised to m as common outside, will the quadratic equation as like this: m square minus 0.3 m minus 0.1 equal to 0. So for the simplification, to make the simplification easy, we are multiplying throughout the both side by 10. We will get the equation, quadratic equation, the same as similar to the equation we'll get as it as 10m square minus 3m minus 1 equal to 0. So the roots are 1 by 2 and minus 1 by 5. Both are real numbers and at the same time they are distinct. So the general solution format will be c1 e raised to 1 by 2 x plus c2 e raised to minus 1 by 5 x. Then the next problem: solve the differential equation x square y double dash minus xy dash plus 5y equal to 0. Substituting y double dash as m into m minus 1 x raised to m minus 2, y dash as m into x raised to m minus 1, and y as x raised to m, and combining the powers, x square into x raised to m minus 2. X square into x raised to m minus 2 will get x raised to 2 plus m minus 2. So we get x raised to m. Okay. Similarly, x raised to 1 into x raised to m minus 1 is x raised to m. So taking x raised to m as outside, and the auxiliary equation will be m square minus 2m plus 5 equal to 0. So the roots are m equal to 1 plus or minus 2i. Here the roots are complex numbers. The value of alpha here is 1 and value of beta, the imaginary part of the complex number, is 2. So if the two roots are complex numbers, this is the general format of the solution format of the given differential equation. So just replace alpha by 1 and beta by 2, will get the solution for the given differential equation as like this: y equal to x into a cos 2 log x plus b sin 2 log x. The next one is an initial value problem. So here we have to find the values of the constants a and b also here. So first find the general solution. The given differential equation is x square d square minus 4xt plus 6 of y equal to 0. This can be also written as x square d square y minus 4x dy plus 6y equal to 0. Okay, this means d square y means d square y by dx square, and dy means dy by dx. Okay, so this can be written as x square d square y by dx square minus 4x into dy by dx plus 6y equal to 0. That is x square y double dash minus 4x into y dash plus 6y equal to 0. Now we are substituting the terms: y double dash as m into m minus 1 x raised to m minus 2, and y dash as m into x raised to m minus 1, and y as x raised to m. Okay, and substituting all these values here and comparing the terms. If we substitute, we will get x square into m minus 1 x raised to m minus 2 minus 4x into m x raised to m minus 1 plus 6x raised to m equal to 0. So x square and x raised to minus 2 can be cancelled. X and x raised to minus 1 will be cancelled. We will get m into m minus 1 into x raised to m minus 4m into x raised to m plus 6x raised to m equal to 0. All the terms contains x raised to m as common, so we can take it outside. M into m minus 1 minus 4m plus 6 into x raised to m equal to 0. So we can take it outside, and the auxiliary equation will be the contained in this bracket term. So m into m minus 1 minus 4m plus 6 equal to 0. This is the auxiliary equation, which is a quadratic equation. M square minus 5m plus 6 equal to 0. So the roots are 2 and 3. So the general solution format will be y equal to c1 x raised to m1 plus c2 x raised to m2. Just replace the m1 as 2 and m2 as 3, which is same as if we replace m1 as 3 and m2 as 2. Both are same. Now we need to find the values of x1 and x2, c1 and c2 here using the initial condition. Our first initial condition is y of 1 equal to 0.4. So the value of x equal to 4 and y equal to 0.4, substitute it here, we will get an equation c1 plus c2 equal to 0.4. Now our next initial condition is y dash of 1 equal to 0. So the value of x will be 1 when y dash will be 0. So we have y as c1 x square plus c2 x cube. So find its first derivative. For substituting this initial condition, it is y dash equal to 2c1 x plus 3c2 x square. Derivative of x square is 2x. Derivative of x cube is 3x square. Okay. Now substitute x equal to 1 and y dash equal to 0. We will get another equation 2c1 plus 3c2 equal to 0. And solving these two equations, we will get the values of c1 and c2. Here the value of c1 is 1.2 and c2 is minus 0.8. Our general solution was y equal to c1 x square plus c2 x cube. So just replace c1 as 1.2 and c2 as 0.8. We'll get the general solution as like this: y equal to 1.2 x square minus 0.8 x cube. This is the format of solving an Euler-Cauchy differential equation. Thank you.